Subscribe to AmpCode and ring the notification bell to get the latest content.
Hello and welcome back. In the earlier lecture, we have seen all about the overview of Apache Kafka and how it works under the hood, and also we have seen its architecture and its core components. So now let's talk about how to do data ingestion using Kafka. So as you already know that in today's day and age, data is growing tremendously, and every big data and every data driven organization is struggling with how to handle and process the big data. Anyone can maybe able to store the data, but to get the insight out of it is pretty difficult. And as per the Forbes report, there is like around quintillion size of the data is generated every day, which is a huge number for everyone. So basically, let's talk about what really is a data ingestion and how it solves the problem of handling the big data. So basically, data ingestion will refer to as a process of collecting the data. Collecting it means that, as you already know, data could be present in the multiple sources. So you are going to collect those data and then store a most unstructured set of data from these multiple sources for further analysis. So basically, we have already know what is data ingestion, but there are like three different layers of data ingestion. The first is the collection layer, where we are collecting the data from various sources and then decide how to integrate with it and how to unify that. And after that, there comes the processing layer, where you are having like the integrity and the quality of the data. Here you are going to transform the data so that it will make sense to the further process, which means that making like sense out of the data and get the hidden patterns out of it. So data analysts, data scientists could easily get the meaning out of it only when, so they will only able to get that only when that format is proper, the right type of data types is there for each column, as well as the data is complete and not having much null values. So the completeness of the data, the quality of the data, as well as the accuracy of the data, there shouldn't be any duplicate records present in your data. So all this all this groundwork needs to be done in the data processing layer. There are like several frameworks that we already know, which is like Apache Spark, then we got a Hadoop, MapReduce to process the data. So it can do both the batch data as well and the real-time approach as well. But right now, industries are struggling with handling the real-time data, because real-time data is pretty suitable for many use cases where the instant action or the instant decision needs to be made, like the recommendation system, where if an person accessing some e-commerce website, then it has to do its groundwork in real time and get the user the required recommendation, product recommendation. So in under the hood, it totally relies on the real-time analytics of that person's information. So basically, the storage layer means that once you got the data into the required format, then you're going to dump it or maybe store it into like the storage layer. It could be data warehouse, data lake house, and you can do all this stuff for real-time data using Kafka. So let's talk about how we can do that in detail. So now let's talk about the step-by-step approach of how to use the Kafka for data ingestion purposes. So basically, it is very important to have a very reliable event-based system. Event-based means the system could be able to handle the real-time data, and it can handle the large volumes of the data, because in the big data application, the data will be generated in a huge amount at high volumes, and this should be done in low latency, means that it shouldn't be any delay, and your machine learning pipeline or your product recommendation system should act quick. So it needs the low latency system, as well as it should be scalable enough to handle large amount of data and any changes in the future. So let's say, for example, in the e-commerce website, it is very essential to have a scalable system. So during the sale or the offer season, that time the consumption will be huge. There will be millions of users accessing your website, and the product recommendation system will work for each of the users. So that will be a lot of groundwork and lot of data that needs to be processed in that time. So your system should be scalable enough so that it could horizontally scale up to accommodate that load during such events, and also it should be fault tolerant to make the system more reliable. And this is where this Kafka for data ingestion comes into picture. So this Kafka is nothing but a framework which will allow you to multiple producers will produce the data from the real-time resources. So it could be like an IoT device, it could be coming from a website or the logs, and then to collaborates with the consumers who ingest that data. So let's talk about the step-by-step approach of how it will happen under the hood. So basically the first step is like producing the data to Kafka for data ingestion. So our data could be coming from multiple sources, which is like event based sources. It could be coming from a temperature sensor, it could be coming from an IoT device, or it could be coming from a website. So basically this data will be coming at a huge volume, high velocity, and from different sources in real time. You have to make sure you don't have to mess up with the ETL approach here. Here we are going to use Kafka instead, and here we are going to use the Kafka Connect for storing the raw data. Raw data means it is not in the required format, because most often real-time data could have garbage values and you have to clean it up to make it more usable in the subsequent phases. Then you got to configure and start the S3 sync connector. What I'm using here is the S3 bucket. So in our example we are going to use the Amazon S3, which is hosted in cloud. So it's a cloud storage which is pretty highly available and a great choice for storing your data and the raw files. So S3 bucket can handle any type of data at high volume, and it is a pretty cost effective and highly available system, and it's a pretty popular choice nowadays in the data community, and many organizations are already migrated their workloads to cloud. So that's why we have taken the example of the S3 bucket here. So basically it will need the configuration of the S3 sync connector. So basically these connectors are provided by Kafka only and we can seamlessly use it, but since Kafka is an open source tool, so there will be a lot of groundwork and a lot of configuration that you want to make as per your use case or as per your needs. Let's talk about the flow of how it will happen. So as you can see, these are nothing but this is nothing but our flow of using the Kafka for data ingestion. The first thing is like we will be having the Kafka producers. So there could be like different sources and different producers where the Kafka can consume the data. It could be FTP source, it could be a Cassandra source. So if you don't know Cassandra, we have already talked about in the previous lecture that Cassandra is nothing but a NoSQL database which works on the column-based approach, which means that it stores the data on a columnar basis and it's a highly efficient NoSQL database. Then we got a WebSocket source. So this example, WebSocket source example, we are going to see in the upcoming lecture, where we will get our hands dirty and set up Kafka and work and publish some data and consume it in real time. So that will be really fun. So the end, and also like there could be multiple sources, so we can consume the data from multiple producers here, and then we can publish that data and store it as a partition in each of the topics. That's up to us. And then after that we will be needing the configuration of the Kafka Connect S3 sync connector. So this Kafka Connect is provided by Kafka only, and we can easily use that connector, and we are going to see it in action as well. And then through that it will pull the data in real time and dump it into the S3 raw data layer. So basically our raw data files will be stored into S3 bucket, and then it could be consumed for the further analysis or maybe a further machine learning or the AI pipeline as per your need. So this is how you can use Kafka for data ingestion. But let's not waste time and get our hands dirty and set up Kafka locally on your local machine, and then we'll see how to publish the data from a WebSocket source or maybe some different sources and then consume it back in real time and how it works under the hood. So I'll see you in the next one.
So that's it for today. I'll see you in the next lecture.